Hello, I Anand Jain from Hanumangarh welcomes you to your favorite Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subjects. Today in our class 12th physics playlist, we'll understand Bohr postulates and how they explain hydrogen-like atom, and we'll also derive radius of nth orbit and velocity of electron in nth orbit for hydrogen-like atom. So let's start and remove all our doubt and confusions regarding Bohr postulates used to explain hydrogen-like atom. Our board examination question pattern is derive expression for orbital radius in nth orbit and velocity of electron in nth orbit for hydrogen-like atom by using Bohr postulates. So we'll first discuss Bohr postulates by three statements. The first is around nucleus electron revolve in a circular orbit and in circular motion. The outward centripetal force mv square by r is balanced by electrostatic attraction between positively charged nucleus and negatively charged electron. The Coulomb electrostatic force between Ze positive charge of nucleus and E electron charge is Ze square upon r square, where r is radius of orbit, and when electron moves with v linear velocity in a circular orbit of radius r, if electron mass is m, then centripetal force is mv square by r, and this is the balance equation between centripetal force and electrostatic attraction force. And by this expression we can represent the velocity of electron in orbit in terms of radius as v square is equal to k Ze square over mr, or we can express radius of orbit in terms of velocity of electron in orbit as k Ze square over mv square. So radius can be expressed in terms of velocity, or velocity can be expressed in terms of radius using this equality of centripetal force and electrostatic attraction. The second statement of Bohr postulate is regarding stationary orbit, and according to that, electron rotates only in some specified stationary orbits where angular momentum of rotating electron get a quantum restriction, and angular momentum of orbiting electron must be integer multiple of h upon 2 pi. So it may be 1 time, 2 time, 3 time, 4 times of h upon 2 pi. Angular momentum with mass of electron m, velocity in orbit v, and radius of orbit r is given as mvr, and as per Bohr quantum restriction of stationary orbit, electron can have angular momentum only integer multiple of h upon 2 pi, where n could be any discrete integer number 1, 2, 3 to infinity. So we can say angular momentum of orbital electron get quantized or have discrete stepped value, and electron can have orbital motion only in those stationary orbits where angular momentum is integer multiple of h upon 2 pi. The third postulate of Bohr theory explain discrete line spectra of hydrogen atom and also describe characteristic of stationary orbit, and it says that when an electron rotates in a stationary orbit where angular momentum has quantum restriction, that orbit is a non-radiating orbit. That means electron in that orbit never emit or absorb energy. Each stationary orbit has a definite amount of energy associated with electron in that orbit, and this energy is minimum at n equal to 1 ground state position in hydrogen atom, and it is minus 13.6 eV, and for other quantum restricted orbit where angular momentum is 2 times h upon 2 pi, it is minus 3.4 eV, where angular momentum is 3 times of h upon 2 pi, it is minus 1.51 eV, and so on. And when electron of one energy state transit to another energy state, electron can absorb or radiate energy. When electron absorb energy, that's called excitation. Electron will move from ground state to higher excited states, and when from higher excited state it comes to lower energy state, it emit or radiate energy. Electron of ground level n equal to 1 can absorb energy in several ways. It can absorb energy when atoms are heated, placed in strong electric field or in magnetic field, or have incidence of high energy photon or atom have a strike of energetic electrons, and when electron absorb energy in ground level n equal to 1, it will excite and can move to n equal to 2, 3, 4 or 5 or higher energy levels. And when electron of higher energy level transit to lower energy level, it will radiate energy in the form of electromagnetic radiation or photon. And if for higher energy level En2, if electron transit to lower energy state En1, then the difference of that energy between two energy levels will emit as a photon, and as per Planck theory, the photon of frequency nu got a energy h nu, and photons are emitted as per energy difference of two energy levels, and this is Bohr frequency condition. We can find out radius of nth orbit electron Rn in hydrogen-like atom by using Bohr postulates. One Bohr postulate is centripetal force of electron having circular motion in nth orbit with velocity v, radius Rn and mass m given as mv square by r get balanced by electrostatic attraction between Ze positive charge of nucleus and E electron charge of electron, and here k is a constant 9 into 10 to the power 9 in MKS unit, and from this expression when Rn square is divided by Rn, it become Rn, and when we brought mv square to other side, the expression of nth orbit radius in terms of velocity become kZe square over mv square, and this become our first equation. Now the second postulate states that angular momentum of electron in nth orbit with mass m, velocity v and radius of orbit Rn given as mvr is integer multiple of h upon 2 pi, so it is nh upon 2 pi, and from this we can say velocity is nh upon 2 pi mrn, and we can substitute the velocity in first expression from second expression, when in this first equation velocity is replaced by second equation as nh upon 2 pi mrn, and it is simplified. It become 2 square 4 k z pi square m square rn square e square in numerator and n square h square m in denominator. Now this Rn square and this Rn when simplified it become Rn, and n square h square to the other side in numerator, 1m get cancel out, and in denominator we got 4 pi square k 1m e square z, and in place of k we can write 1 upon 4 pi epsilon, and this is n square by z multiplied by this k is written as 1 upon 4 pi epsilon, 4 pi get cancel out, and this expression finally become epsilon naught h square divided by pi m e square, and all are constant. Epsilon is permittivity of air 8.854 into 10 to the power minus 12 Faraday per meter. H is Planck constant 6.6 into 10 to the power minus 34 joule second. M is electron mass, E is electron charge, and when this is simplified it comes as 0.529 angstrom. And the proportional relation for radius of nth orbit is n square by z, and this expression is valid to all hydrogen-like atom. That means for singly ionized helium or doubly ionized lithium also have the same radius relation, and this clearly indicate that for higher value of z, same lithium with Z3, the radius of first orbit is 1/3 of 0.529 angstrom. And this expression also say that in hydrogen where z is 1, the radius of first orbit is 0.529 angstrom, and for orbit it is 4 times, for third orbit it is 9 times, and for fourth orbit it is 16 times, as radius of nth orbit is proportional to n square. We can also derive expression for velocity of electron in nth orbit for hydrogen-like atom. Our one postulate says that centripetal force mv square by r get balanced by electrostatic attraction between nucleus charge and electronic charge kZe square over Rn square, and this gives relation of radius in nth orbit as kZe square over mv square. This become our first equation, and the second postulate says that angular moment of electron in nth orbit, product of mass, velocity and radius, is integer multiple of h upon 2 pi, or is nh upon 2 pi, and this gives velocity as nh upon 2 pi mr. And in this expression, if we replace radius expression in terms of velocity from first equations, we'll find that velocity is nh upon 2 pi m, and in place of radius of nth orbit we have written kz square over mv square. Now this denomination in denominator come in numerator, so it is nhmv square, and now denominator is 2 pi m kz square. V square with v gets simplified as velocity, and transformation of this from denominator to second side in numerator become 2 pi m z square, and the remaining term here is nhm, and in place of k we have written 1 upon 4 pi epsilon naught, and z and n when brought out, the remaining expression after simplification is E square upon 2 epsilon h, where E is electronic charge, epsilon is permittivity of air, h is Planck constant, all are constant, and this constant when solved got a numeric expression 2.2 into 10 to the power 6 meter per second. So for hydrogen like atom, for atomic number z and nth orbit, the velocity is 2.2 into 10 to the power 6 z over n meter per second, and it clearly indicate that for hydrogen z is equal to 1 in first orbit, velocity is 2.2 into 10 to the power 6 meter per second. In second orbit it is half of it, 1.1 into 10 to the power 6 meter per second, and in higher n value, velocity inverse function of n decreases. We hope this beautiful learning video has solved one of probable board examination question which you may face, and now you understand what are Bohr postulates for hydrogen like atom, and you can also derive expression for radius of nth orbit or velocity of electron in nth orbit for hydrogen like atom. Our other learning video of Confused in Physics series are equally useful. You can use them in your studies or refer them to your friends also. So share this knowledge, as when you spread knowledge you increase your knowledge. Happy learning. Have a nice time. Thank you very much.